Hugo, it's really a pleasure to have you today here in the Transformers podcast. Uh, in fact, we had already a couple of discussions together, quite insightful discussions about the world of AI and all these hype that we are living nowadays. Um, First of all, Hugo, I would like just for the audience, just for you to make a short introduction of yourself, and then we will start to talk about some topics on AI. Yeah?
Thank you. Thank you for having me here, Pedro. It's my pleasure. I really love talking with you about these topics, and it's great for me also to share my opinions and how I see things. So glad that we can make this also broader. So I'm Hugo. I'm currently working at Google, working on BARD, and I'm based on in Zurich.
Mhm.
But this all started on long time ago, and I'm an aerospace engineer from Technic in Lisbon and the Delft University of Technology in the Netherlands. So completely changed the field some years ago. Worked some years with the European Space Agency projects, but after seeing that it was moving too slow, I moved to a field that was just starting,
Mhm.
such as data science, which was just popping up and everybody was talking about it, same as AI right now.
Yeah, exactly.
And I felt really like the drive to I have to catch this train. So I just jumped aboard, learned on my own a lot of stuff because there were no online courses, no masters on that. So I decided to I'll learn. I'll try to change my field. I just want to be part of this. And I joined a startup in Lisbon called James,
Mhm.
which was on credit risk AI, and I worked there for 3 years until 2019, where Google acquired this company. And we were at the time around 25, 30 people, and we all moved to New York City to be part of Google Payments business area.
Mhm.
And I worked at Google there as a software engineer, mostly a little bit farther from AI, to say the least.
Mhm.
And but then I got into like after 1 2 years at Google, I got again into like I really have to be part of this again, and I
Yeah.
didn't want to lose the train again, and I just tried to move to more interesting projects. And since last year, and in August, I moved back to Europe to the BARD team in Zurich, where I'm working right now as a software engineer and like creating new features for BARD.
That's
And yeah.
amazing. Your road and the way that you enter in the sector of AI, it's really impressive. So first of all, congratulations for that.
Thank you.
Um, picking exactly that point. y- One of the points that I have for this session, in order that we can discuss a little bit together and share also with the audience, is there is, as you know, there is a big hype around the future of artificial intelligence, more concretely about artificial general intelligence. Yeah, there are some people
Mhm.
that saying that we will be all dominate the human race. All of them says, some of them says, let's calm down a little bit of this fever,
Yeah.
because in fact we are still far away, and the models that we have nowadays are not even surpassing a kid of 4 years old. So
Yeah.
there is a lot of misinformation around this topic. One of the things that I'm trying, let's say, to do in this stage, it's try to elucidate a little bit the people, and I'm writing an article around, okay, what is the future of AGI in concrete, and especially to give to the audience what are nowadays the capabilities of transformers, because this is let's say the most common AI technique used on like in GPT, like in others, and especially what are the limitations. Yeah.
Yeah,
So I would
that's yeah.
Yeah, so I would like that you, as a an expert on this area, that you give to the audience a little bit what are, let's say, uh, the capabilities of transformers, but especially giving a real notion about what are the limitations of transformers at this stage.
Yeah, so this is like a very like there's so much going on. Like so transformers like this architecture came up in 2017 or 18, something like that. And since then, like the first 1 or 2 years, it was not just like so big as it was in the last year. Now everybody adopted it. It's like everybody is using this.
Mhm.
And it's something that since we are in the early stages, it's not very optimized. The first point is it requires a lot of computation,
Mhm.
and not everyone can have like models that are as big as the ones behind BARD or ChatGPT. So there's this limitation. That's why we start to see some open source like Llama or Mistral AI, like they are coming up with the optimization so that the researchers can also work with this, right? So there's this computational cost that is still very high, which is a limitation.
Mhm.
Oh, another limitation that I see personally is that you can see them as they are like their information is like the base model, the large language model, that the base model is static. So they are trained on a huge amount of data. And but the problem is that they do not update themselves. So why how do people are fixing this nowadays? They for example uh, in the early days the best example is the early days of ChatGPT that you would ask like what happened yesterday in the world, and it would say like my knowledge is only until
Yeah, yeah,
2021
yeah.
September, and you remember this. So this is not no longer a problem because the the base model is still static, but they had something called retrieval augmentation generation, RAG, let's
Yeah,
call
yeah.
it RAG, and it connects to the web. And when the large language model understands that this is a new information that I may not know, so it goes to the internet, as ChatGPT is doing, and they fetch, they call like they retrieve information to augment their knowledge, and this is a way to fix it. But the problem is still
It's
there.
still there.
It's still a static model. We need it. It's still a static language model that maybe it's updated every 6 months or every year because it costs millions of euros or dollars, right? So this is another thing, the static, and also like the so-called hallucination, right? It's um,
Mhm.
it's difficult because it's difficult to solve because the only thing that large language models do is hallucinate. They just hallucinate,
Yeah, yeah.
but most of the times they just hallucinate truth, right? The right things, hopefully, like 95%. The bad thing is when they hallucinate things that they shouldn't, and that's the wrong part. That's how with maybe these also again engineer solution around them, the retrieval augmented generation, they try to validate what they are actually saying. So hallucination is also a great problem. And yeah, I think that the computational cost, the like the static knowledge of this, and the hallucinations that are still an issue to solve are like the biggest problems. But nevertheless, the capabilities of these large language models are huge, as we see every day. I think that a lot of people. So I use them every day. I'm biased, I know. I work it hard, but I use this every day to help me work on my work. And I already felt sometimes, especially on coding, it's simply for me it's amazing. I can give it an idea of what I want to do. I can give it an error of my code, and it can help me at least think through the problem, which is amazing. And I noticed the other day that I was simply amazed. It was Friday afternoon, and I had a bug on my code. And I know that if it was 2 years ago, I would spend like 1 or 2 days trying to fix it. But then I used a large language model to help me out, figure it out. And I simply became more productive. I fixed it in about 2-3 hours, which is like impressive. It was very impressive for me to feel like, okay, this is really impactful. I'm feeling it at this moment that this is going to change. And people shouldn't be much afraid of it. What people should be afraid of is, if you do not use this, you should be afraid of it, because you're going to be left behind. You're not going to be as productive as a person using it. That's what you should be worrying about, not about AI going to dominate the world. This is AI is just simply another tool that we use to solve problems, problems of humans, not problems of machines. So the end goal is still the human. This is just another tool. That's how I see it.
As any other technology introduction period that we had during our history, there is always this phase that we have a paradigm between different opinions regarding the technology hype. Yeah, it was the same when it appears the social networks. It was the same when the internet itself appears. So I think this is a question of time, and humans need a certain period of time to to get used to a change in the environment.
Definitely. And the thing that people were so shocked, maybe compared to other technological changes, is the pace of this.
Indeed.
This is really the last year, the last 12 months, let's say like 16 months since ChatGPT came out. It was massive. Like it's very difficult to keep up with everything. I cannot keep up with the amount of information that is coming out of this field, and I'm in the field, so I cannot even imagine people that are just outside and they see, like, if you are in coma for 16 months, and suddenly you wake up and what, computers now can do this? You can simply ask it to write me an email, and with just some ideas. This was not broadly available 16 months ago. So it's like the pace is huge.
Indeed.
And
Indeed.
and there's something that, even though the pace is huge, we'll see something that always happens that you were starting to mention. For example, the hype, right? There's a hype. The hype on like last year on March, April was huge. Now people start to get a little bit used to this and start to use it. Some others say, I still don't feel the need, or I still don't have a use case for this. Totally legit. Some of these tools are not production ready yet to be useful for some cases. But there's a graph that I always try to use, that is the Gartner hype cycle. Which is like, last year, around March, April, May, it was like the top.
Top.
Everyone was starting to use this. Everyone was talking about it. Twitter was crazy about it. Papers popping up. Still papers are popping up, but like you start to feel that now things will come up, as now products will be developed around this. And there's a lot of companies that are starting. There's a lot of big companies also investing. But unfortunately, I don't think there will be space for everyone, as it was in the .com crisis, right?
Exactly.
Bubble, right? There will be a point where, some will succeed, some will not, as always. But good things will come out of this bubble. There will be some very good use cases that will remain. And for example, I don't think that helping me out with C++ code will go away. There will be a lot of developers that will still need it.
For sure.
The thing is, who are the ones that will still be here to help the developers with this. So that because right now there's a huge flow of people trying to solve this.
Mm-hmm. You know, one thing that and now returning a little bit back to the topic of hype on generative AI, one of the things that probably not all the people know is what it's behind transformers. Because in reality, what we are talking is just a brilliant, I'm not saying that it's not brilliant, but a brilliant architecture on neural networks that predicts the sequence of words. So when people start to talk with me, and once again, we are talking just about the base model, let's say, without any um, framework around that, like RAG or anything else. But the model itself, as you said, it's, you know, they don't learn, so they are static. So
Yeah.
there is no any kind of understanding on the context in the sense of
Yep.
reasoning and decision making. There is no rational. It's just, you know, an input, and then they are just calculating the best probability for the next word. Yeah.
Yeah. That's basically it. And how people are trying to solve this is as you is sometimes it's like a competition. Who has the biggest context window?
Exactly.
Like, oh, I can handle a whole book. Oh, I can handle just 1,000 tokens.
Exactly.
Like it's very tough also because the things that you put on the prompt, they can sometimes be noisy. You cannot put everything there,
Mm-hmm.
and sometimes even where it in the prompt it is relevant.
Yeah.
So there's even papers that one that is called, I think, Lost in the Middle, that it specifies that hey, you can have a huge prompt like 32,000 tokens. I don't know how much, how many, like how long it is the ChatGPT token, maybe 32,000 right now, something like
I
that.
think so.
Yeah, it's a lot. It's like a small book or something like that. So you can try, but the thing is, the LLM will kind of focus on more some areas like like the bottom ones or on the ones on the top, and the middle sometimes it's a problem.
Yep.
Or sometimes you don't even know. Like this is all ingested by that attention mechanism. It's very complex
Mm-hmm.
how it will. And one of the things that that I worked before joining Google that I was really proud and like I was really enjoying working on was explainability.
Yeah.
And it's very difficult right now to have the LLM like having like an independent system explaining why did you give me that answer.
Mm-hmm.
Like what did you use to give me that answer? What were the weights, or like how were the keywords that were more relevant for you to give me that answer?
Mm-hmm.
And it's like a black box, right?
Correct.
It's very difficult to understand what's going on beneath it. That's why, like, I think that for regulation, it's going to be very difficult to understand, like, how do you make these big companies output the explainability of these models? If they are if they start to be used, being used as like in courts, or to select people for hiring for a new position in a company, it's going to be very complex because the data is like might be biased, right?
Correct.
Um, or the data might be wrong.
Mm-hmm.
It's very difficult because it's trillions of tokens that they are used to train these models. So yeah, there's these limitations that we need to take into account.
Yeah, and picking up these limitations that we were talking, you know, one of the a kind of exercise that I was trying to do myself was to try to identify, picking up, the several research that we have nowadays, and the people need to understand that behind transformers, there is a lot of, let's say, studies around also on transformers, but also on other kinds of neural networks and also other techniques, like, for example, hybrid models. But before we go into that, generally, and looking for the constraints that we have nowadays, um, having as a target vision the AGI, what are
Mhm.
what are the techniques, let's call like this, what are the techniques that you predict that will be focused during 2024 in terms of uh, mitigating these actual limitations that we have on in transformers and looking for the future of what we can call artificial general intelligence?
Yeah, it's first artificial general intelligence. The definition is so complex, right?
Indeed.
If we look at
Indeed.
10 years ago, and we were said that today would look like what we're seeing today, it would say, "Oh, that's AGI." Yeah, definitely AGI. I'm sure, like we're doomed, and
Indeed. Indeed.
but now we're thinking, "Oh no, this is still not AGI." Yeah, I agree. This is not AGI. It's definitely not AGI, and feel like we're still like a little bit far, but not totally far. There are still a lot of limitations on these models, and they are still inside in general, they are still inside a computer. They are software, right?
Mhm.
It's scary when they start to become a robot, and when they start to have image, for example, as an input, or sound, and maybe or other sensors like thermal sensors and other things. That's scary, um, and it can think faster than a human. So for AGI, let's say, like, I don't know exactly what AGI will look like, but I think that we need to have some more like breakthrough beyond transformers. I think that it's great, works well on a lot of fields. Like they solve a lot of problems, like help you code, help you find the best recipes for tonight, help you, I don't know, plan a trip or something like that.
Mhm.
But going beyond that, really having a capability to reason and to go beyond what already we could do on our own, it's very difficult, and I feel that they know more than us, the LLMs, because they are just training on a lot of data. The reasoning is still not there, so we might need to still continue growing the models in terms of size, number of parameters. But I feel that there's still a need for a new like breakthrough in the tech. Not just Transformers, maybe Transformers 2 or something like that, or not even Transformers. I feel there's something still missing.
Mhm.
And I bet there's a lot of great people working already on the research to try to come up with a new future version of these techniques, taking into account all the limitations that I mentioned and even more that they might find. So one of the things that we've been seeing to try to overcome this is to have some multi LLMs, each one specialized in a different field. For example, we even talked before about multi-agents, right? So these multi-agents, you can try to have some like specialized in a field, the other one specialized in another one, and maybe having a generalist that is the planner or something like that, that is like the program manager, a product manager that is handling all of these smaller agents that are specialized in something. And you can give it a task, a global task that is very, very ambiguous, very broad, very difficult to solve. But then this is then spread out across multiple smaller experts, as we've been seeing I think it's called mixture of experts, right?
Yeah,
So
correct.
there's a lot of even nomenclature that I'm not even aware of, because everything is changing so quickly. But this is like something very interesting. I really found amazing. An amazing example was last year. I think it was mid-year, mid 2023, where I was still in New York with my colleagues at Google, and we heard about the paper that was a small. It looked like Pokemon, or I don't know, an indie game, where each uh, player there was just an LLM, and they had a task like.
Yeah, yeah, yeah.
Plan a party or plan a wedding. I don't remember exactly. And each one had their own personality. So some of
I
them
think it
just
was.
like, I'm not going, I don't like
I
this.
think it was Minecraft, the paper around Minecraft and the multi-agent system for video games. It was around that.
Oh, there was one that was Minecraft. I think there was another one. I don't remember the name now. I think it was something like generative agents,
Yeah, yeah,
and it was trying to simulate a human behavior, and
yeah.
it was pretty amazing to see like it started to resemble a little bit of this of ourselves as well. And each element there was an LLM. That's where like we might need to go, at least as an intermediate step, with this mixture of experts. That's what I see. And this mixture of experts, each one of them could have access to a different capability outside with the retrieval that could also bring, and then they connect again and try to go towards their goal. Uh,
Mhm.
what exists, just to finish, like right nowadays, it was something. It's already some months old. It's like the baby AGI and Auto GPT. They were trying to fix this with
Correct.
this spread out of chain of thought and tree of thought
Hmm.
techniques.
Correct. Yeah, yeah.
Yeah.
I think that uh, in my opinion, and I would like also to hear your view. Is, as you said, mixture of experts. It's and I don't want to take let's say the big result that Mixtral was getting with this model that they were launching, the 8 7B, that in fact it was basically using that concept of having you know different kind of architectures, transformers trained in different kinds of data, and then to have the router that, depending on the question, will infer into different models. I think it's a good step. Nevertheless, I continue to think that all these models, once again, will continue to calculate probabilities of the next word. So, one of the things that I was, let's say, trying to research was, because there is a basic problem, yeah? And even looking to the name artificial general intelligence, the biggest problem that we have nowadays in the models is that they are not able to generalize knowledge. So they are not able to pick up something that they know, and if the environment change, they are not able to use that knowledge, even if it's exactly the same, a different environment, but with the same, let's say, with the same conditions. They are not able to adapt because they were
Yep.
not trained for that. So for me, that it's the basic constraint on artificial general intelligence. And based on that, there are a lot of research. One is around neurosymbolic models. Um, Also, we are seeing, and we saw a couple of models going a little bit beyond transformers, that are using a kind of stateful models. In the case of, for example, Mamba, that it was a model recently published that it's based on state space model that basically use and don't lose the context of previous inference, and it stores the
Mhm.
states of the neural nodes. Um, so I believe that there are, let's say, a couple of other architectures that are flowing on top of just, combining transformers. Yeah.
Yes.
What is your view regarding that kind of techniques? Do you think that um, we will be able to solve with one single um, technology, or we should think that we will only be able to achieve a kind of AGI with what we call hybrid models? So a combination of different kinds of models, like a transformer with the SSM, or you know, what is your
Mhm.
opinion regarding that field?
So I think and that's a very good question. This is like predicting the future, but so the limitation is there. They are stateless. That's a problem. They are an engineer solution RAG on top of it is trying to fix something. And even without RAG, like
Mhm.
even if you prompt it very well and try to figure out, like the a large language models sometimes do create associations that were maybe not exactly on the data that they were trained on, these associations. And you sometimes see, and I feel like sometimes like, oh, that's I was not thinking about it. That's a nice idea. Like maybe coming up with a recipe that it's nowhere to be found, but it's thought about tastes and the acid and saltiness, and it maybe makes some associations that sometimes they feel like they spark a little bit the AGI,
Mhm.
but not yet. So they are still when you do this, they are still not improving themselves, and they are not changing their behavior. If you ask the same question, it's just a probabilistic answer again. You might never get that again, that spark that you got the first time. So it's just probabilities. Um, the thing that you touched on, like this state, adding a state, I think it's going to be something interesting because we might start to see something this year or next year about this because like if you when we talk humans among humans, like
Mhm.
when we talk when I talk with you, if I talk with you tomorrow, we kind of remember what we talked about today, right? So it's not just a painful because I don't have to mention everything that we talked about the day before,
Mhm.
right? So these kind of updates, they need to be created somehow. They can be solved again, trying to come up with a solution on RAG, but maybe we need something more, and that's where the research is needed, um, and that's what we were waiting for as well. And talking about like a general model or a mixture of experts, we can also think as humans, and it's not just one human, one knowledge in the world, right? So we have multiple experts in the world, multiple capabilities, people with different understanding,
Mhm.
people with different opinions. So I think that it's difficult to imagine just one single model because one single model it's going to be much more expensive and centralized, uh, and then just having smaller models where you can control more easily each one of them.
Mhm.
So you can control maybe it's just a model for coding that is more specialized on coding, and sometimes when just something like the planner or router, whatever you call it,
Mhm.
when it feels the need to call that one, it calls that one. That's how I see it because that one can be it's like contained. It's like you can fix it in a more controlled way than if you just have one that it does the coding, does the recommendations, does everything. It's going to be much harder and expensive computationally because you have to retrain everything,
Mhm.
right?
Correct.
So if it's just that one that is smaller, but it's amazing at what it does, um, that's how I see it. Like having more, at least as a first stage, I feel that this is where it's going.
Mm-hmm.
Maybe 5 years from now or 4. No, 5 years, it's impossible to predict. Or maybe 3, I don't know. We'll see that a general one will work. But I like in the short term, I don't see that. It's much harder, and it's easier for the developers to solve this because the problem is there
Mm-hmm.
in that one. It's not just, oh, our general model has a problem. Now we have to retrain everything. It's going to cost millions.
As you know, and now picking a little bit the topic of multimodality, a lot of people are talking about, let's say, in one of the interviews, Sam Altman was talking a little bit about giving some, let's say, rumors about the future of GPT-5. Yeah? Um, and one of the things that it's expected is that in terms of multimodality, there will be some news. Um, do you think that the increase of input types, and picking up what you were saying, that probably some companies will try to put the models even bigger and try to mix the capacity of fine tuning and learning using a combination of several inputs. One of the things that um, people are saying, and I tend to agree, is that we have already these models trained with a bunch of data, but there is a lot of knowledge that we have in the world that can only be learned with a combination of inputs like video and text and so on. And
Yep.
that's the reason why there is already some research about fine tuning models with multimodal information. Uh, do you think that what we will achieve with multimodality this year in 2024? What do you think are the steps right now after image,
Yeah.
text? What do you think?
Yeah. I'm very happy that you asked this question. So yeah, I think that last year was a year of text,
Mm-hmm.
the year of feeling like we're back to the 90s or the early 2000s, where we just write down in chatbots and try to come up with something. So it was still impressive. It's still impressive nowadays. But the multimodality will it's going to explode this year. That's my expectation. There were some companies that already started to going viral on this. Humane AI, which was a pin, and Rabbits are one,
Yeah,
I think,
yeah.
which is also that's a very impressive one. They are bringing this kind of multimodality. The problem is computational. Computation is like extremely expensive, and also like the models are still not there. But multimodality is the only path forward, in my opinion.
Mm-hmm.
It's the only way. It's how humans perceive the world. So we want also AI to perceive the world as we perceive it as well.
Correct.
So I talk with you with sound, but it's easier for me if I also see your video, if your expressions on your face. I can you might fake what you're saying
Body language can
in
say a
the
lot of things.
yes, that's true. So that's where I'm going. Maybe like you can be very sarcastic with an LLM, and it does not.
Yeah,
It's
yeah.
not seeing your face.
Yeah.
It's not understanding how you are pronouncing things. It's just dumb right now. It does not understand that. It
Indeed.
has a huge limitation there. Once we start having this, and also very, very difficult will be the training data that will be used for this. It's extremely difficult.
Mhm.
How do you find like sarcastic videos? Well, you can go to YouTube and download like tons of it, most likely. But you have to annotate them. You have to start creating these data sets, huge data sets that compared to text, they are orders of magnitude bigger than text, right? It's massive. So again, we'll have like a huge block on the computational cost of this, but it's the start. So the start will be maybe sound, but usually sound is just translated into text. So it's just a processing that is done and then translated into text. So it's not actually sound. It does not. It does not understand like the sarcastic, the jokes, laughing. Right? It does not understand that because it's translated directly into text. But sound reads the feeling. It's the next step. Image is the next step, and then the forward one, and then video finally. And that's and when everything comes together with the text, sound, video, image comes together and in just one representation, and here we can use the human brain as an analogy, because everything is here, right, in our brain. When we build this and into one representation, it's going to be amazing. And that's where people might say, oh no, if we put this now in the robots that has eyes, can hear, can walk, and has access to a gun, it's very dangerous, right? Yes, it is. We should control that. But there's no way to stop this technology to move forward. If we have European Union or US or creating regulation for this, then we'll have other countries that maybe are not so much that shouldn't have access to this technology. They will also
They will continue. They will continue to develop.
And other people that are less well intended, they will create this, then they will be in front of us and will not be prepared. So the technology will happen. Now, where will it happen? Where you give companies and research universities the better chances to come up with the best technology. So don't block them. That's what I would say.
Allow me to make you a question, just to get your personal view, considering that you touch on legislation. That I think it's another topic for 2024. I think that there will be a lot of discussions around legislation. Do you think that because nowadays the focus of these legislations, and especially in United States, what the people are seeing is that they are too much, let's say, concentrated on proprietary models and big companies. And some people are saying that, probably the real danger, it's on open source models because it's available to everybody. So there is a paradox between, between security and, on the other side, innovation, the power of innovation, democratization of innovation. What is your view? Do you think that really open source should be also focus of legislation, or do you think that this will kill completely the democratization of innovation?
I truly believe on open source. So that's how our startup our startup was possible due to open source before being acquired by Google, because we had access to a lot of people that were not being paid. Not like the only motivation for them was to move the tech forward and sharing it with others. And that's how we, in our startup, could also use that technology and contribute as well to everything. Also, Google, even though there's a lot of proprietary models, of course, but there's a lot of things that Google open source, such as TensorFlow. Like the Transformers paper was done by a team at Google. I don't know if it was DeepMind or the Google AI or research, but it was from Google, right? So this is important to move things forward quickly. And also open source is good because it keeps like everyone can look at the code, everyone can understand what's behind it. It's safer in a sense, right? It's not just a small few selected that have access to it. Of course, the proprietary models will still be needed, otherwise it will not be like a competitive advantage for big companies or even startups. But open source is necessary as well for others to create new companies, for others to learn how things work, for universities to use as well, to for their students, because like resources are very limited in universities.
Indeed.
So you have to use open source. You cannot buy subscriptions as any rich company. Like so, this open source is very important.
Hmm.
Even and I don't think that it should be like it should not make regulators afraid. It should even be like something good,
Hmm.
because they can see it there and everyone can use it. Yes, but that's how like we should have control for everything. That's like, yeah, guns are available, but yeah, people have rules, right? And there's cops, and there's like there's everything, right? So there's rules around it. um I think that i- making it open source or not will not be the reason why bad actors will use these technologies for bad things. So they will also have technologies on their own that we don't even know as well. So
Hmm.
I think we should care less if open source will be a problem for everyone.
Very good. Very good. Hugo, as a last topic, very quickly, and I would
Yes.
like to first thank you for your exclusive feedback prior to the publishment of the article that I wrote on multi-agent systems with Shail Chiara. Thank you for that. Uh,
Yeah.
what do you think that we will be able to achieve with multi-agent systems, and what
Yeah.
do you think are the limitations nowadays that we have in order to apply these in complex scenarios? Because nowadays we see already being applied, and it's important to differentiate what it's really the sense of multi-agent systems, because sometimes people try to confuse um, systems like baby AGI and others, because what these programs are doing is it's a kind of um, using the same model to kind of make a sequential chain of thought. Yeah.
Hmm.
And when we talk about, or the way that I see multi-agent systems, it's in a way that you can have even multi-agents being working in a parallel way, so not in a sequence but even in a
Yes.
concurrent way, and having clustering inside the hierarchical architecture
Yes.
and so on. So it's more than just a baby AGI or something like that. So
Yep.
once again, what are the actual limitations that we have on these kind of systems to apply in the real world, and at the same time, what are the potentials that you see with these kind of systems?
Yeah, so let's start with the potential. I think that these like these multi agents it's when these will arrive to the industry. This is like the big application on industry. Right now, we're still like very much focused on being at a computer, chatting with bards and asking questions. But when these kind of technologies become like multi agents and they arrive to the industry, and I'm going to give you some examples where I feel that's going to be very important. Like they like this is where it on that Gartner hype cycle we arrive to the last part where is the plateau of productivity or
Yeah.
something like that. I don't fully remember the name, but that's where we need to be.
Hmm.
For example, uh, one thing that for many years we've been trying to solve was autonomous vehicles, right?
Correct.
So when they can work as a grid and each node is kind of an agent. It's going to be amazing. One thing that I keep on thinking sometimes when I'm driving is in 10 or like in maybe when my kids will be at the age of driving, they will tell their father like were you, like you were the one driving the car?
Yeah, 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 yeah,
How,
yeah.
like how
Yeah,
was
yeah.
this even legal? Like I think that it's the same thing that we think nowadays. Like people were driving like without the seatbelts, right? Now think, we should use it. No airbags. Like we can think like 20, 30 years ago,
Yeah.
right? How dangerous was it? And 20, 30 years from now, it's all things like humans were driving cars? Crazy. So in 20, 30 years, we'll need these grids, these agents. Maybe each car has an agent or even multiple
Mhm.
agents. That's one example that I see. Another one that is like very like more government level. It's like energy grids as well.
Mhm.
It's one that I feel that it's going to have a huge impact for optimizations, for detecting failures. For like right now, we have a lot of rule-based detection
Yep.
systems that are just if else. We, like we need to, or rejects. Like we need to move away from that, and we'll move away from that eventually with these kind of agents, with intelligent systems that are optimized for these type of tasks. And one that is also very important, especially like due to all these environmental changes that we see nowadays, is like environmental monitoring. Deploying these um agents in different scenarios, different places, and having some like maybe a centralized one
Mhm.
that can think about inputs from the others and can reason on top of it. Again, no if else's, no rejects, no very limited stateless class models, something that updates itself and understands the environment through the input of multiple agents in different scenarios. So that's like some of the that are very interesting. Others could be like logistics as well, optimizations
Mhm.
of logistics. But those are the ones that I see the most important things. Then we have the limitations that you talked about, right?
Right.
We'll have a lot of limitations on the coordination of those, like how not to like freeze, like the main agent, or if it's a centralized one, how to avoid it to freeze. The scalability and like the computational cost nowadays, like to have a deployed agent is expensive, right? We cannot have like a if we want to measure the humidity of a place, it's very expensive if you put like an LLM there, right? So you need to create these very optimized, very small agents that are smart enough for that task in specific. Again, that's why like I imagine that we're going to be full of a lot of agents, not just a general one, because of all the cost and all the focus of each task.
Mhm.
And these small ones will be very important for these very specific tasks, but they can still reason on the tasks that are mandated to.
Mhm.
So yeah, I think that's one of the things, and also again, interpretability or explainability of these models will always be a pain, and that's where people will start asking questions: why did you tell me this? Why is this number the one that you think it's the right one?
Yep. I think
Okay.
that it will be a year where, um, I think that that paradigm that we had in the past, or the target that, every model that was launched, all the people were doing was just looking to the number of the parameters or neurons that they have. So bigger, it's better. I'm seeing
Mhm.
now a trend on better performance with less, investing
Yes,
on
totally agree.
investing on data quality, and we saw some good results in some models that were launched now in the end of the year, that they were basically exploring better the data quality topic. And then of course I'm seeing also a lot of evolution on techniques like quantization and so on, that I think that it will help also on this road. So
Yep.
yeah, I think that we will have a year with a wide range on advancements. um Hugo, many thanks for your time, your availability, and also
It
your
was my pleasure.
insightful
Thank you.
view on these topics. I hope that we can do a live session soon when you will be here in Portugal with more time. And
Happy to do it.
yeah, I think that it will be fruitful for everybody, in order that we could, let's say, share a little bit more insights regarding this field, and also give the opportunity to other people also to interact with us. So thank you once
Mhm.
again, Hugo. Let's keep in touch, and um, I hope that you have a continuation of your beautiful performance on your professional life as you are having right now. Yeah.
Thank you so much, and also like huge success for the podcast. It's very good to have like opinions being shared and to think about this topic since it's so up to date right now.
Thank you. Thank you, Hugo.